In this video, we're going to look at a vulnerability that is related to both cross-site scripting and also to an attack that we saw earlier, session hijacking, but it's a little bit different from both. The idea here is that the attacker gets the user to execute requests on the attacker's behalf within a session that the user has set up. Okay, so it's really simple. The user logs into a bank, a legitimate bank, and the bank, as part of the the session, it sets up this session identifier in a cookie. Okay, so every subsequent request of the user to that bank will carry that cookie. Now, if the attacker knows or suspects or hopes that the victim has a session, an active session to bank.com, what the attacker can do is craft a page and make sure that the user accesses the malicious page or lure the user to access that malicious page. That contains a link such as this one. So there's an image which has to be obtained from, oh, look at that, bank.com, the legitimate bank.com. And now it contains parameters to transfer money to the attacker's account. Now, if the browser will try to fetch that image, it means a GET request will be sent to bank.com to do the transfer, and the cookie is automatically attached to this request. So the session ID is legitimate. Within the legitimate session of the victim, a request on behalf of the attacker has been carried out. And we refer to this as a confused deputy because the browser is confused. That's a deputy. It's confused deputy. It's confused because it uses the victim's authority to carry out a request on behalf of the attacker. Now, what can we do to stop cross-site request forgery? Well, we can use tokens, csrf tokens, and we have separate, slightly different implementations for HTML only pages or pages where the web application uses JavaScript. Let's have a look at the HTML only version first. So in this case, what we will do is, as a web server, embed a secret token for every request. So it has to have a unique value for every request. And we do this in all the HTML forms. And this will be verified on the server side. For instance, we can add an hidden field here, which has the name csrf token and a value that is unique and not predictable. So every legitimate request that the user sends to the server, to the legitimate server, will carry this secret token. Okay. And that can be verified. However, an attack sent by the a request sent by the attacker, so a URL crafted by the attacker, doesn't know this secret token. Okay, so the token, as long as it's unique, non-predictable, will verify that this is a request coming from the legitimate user and not something that was crafted by somebody else. And you can use any method to generate such a unique token as long as it's unpredictable and unique. And one way in which you can do that is simply use a random seed and then take hashes progressively, keep making hash calculations on the result that you have. So hash it once, and then you hash that, and then you hash that, and so on. A hash chain, as it's known. Okay. Now, this was the situation for HTML only. What happens if the web application uses JavaScript? Well, in that case, we work with a similar but slightly different scheme, where on login, the web application creates, again, a unique token, right? So this unique and random value, but sets it as a cookie. So this cookie will be sent to the client, and all subsequent requests sent by the client to the server will carry that cookie. But now the JavaScript of the web application will, every time it interacts with the server, it will obtain the cookie because it can, and then copy that into a new header, a new HTTP header. In this case, we've called the new header X csrf token, right? So this value that was in the cookie was copied into this new HTTP header, and that will be sent to the server, and that's what the server will validate. Now, perhaps this is a little counterintuitive because the cookie is there and will be sent anyway, but now you're copying it. Why do we do this? Well, the reason for that is that only the JavaScript that is from the legitimate domain, from the same origin, in other words, is able to access this cookie. And the attacker cannot access this. Remember, we're protecting against cross-site request forgery, not cross-site scripting or other things. So the attacker doesn't have access to this cookie. Okay. So JavaScript running from a rogue file or email will not be able to access this cookie and copy that into this extra CSRF header. Okay. So the CSRF token cookie will still be sent to the server, but that is not used to validate the request. It's actually this CSRF token header that will be used. Okay. That's how we stop cross-site request